Hey guys, welcome to the first module of the machine learning course by Uplatz. So the first module will be about the introduction to the linear algebra for machine learning. So we will learn in this first module the linear algebra that is needed to learn machine learning. Okay, so linear algebra is a field of mathematics that is universally agreed to be a requirement to a deeper understanding of machine learning. So if you are interested in the machine learning codes, then the first thing you need to do is go through the basics of linear algebra. Okay, so in this, the first module of this machine learning course, I will be covering the basics of linear algebra needed for the machine learning. Okay, so let's begin. The concepts of linear algebra are crucial for understanding the theory of machine learning, especially for deep learning. They give you better intuition for how algorithms really work, which enables you to make better decisions. So if you really want to be a professional in this field, you cannot escape mastering some of its concepts. This lecture will give you an introduction to the most important concepts of linear algebra that are used in machine learning. In linear algebra, data is represented by linear equations, which are presented in the form of matrix and vectors. Therefore, you are mostly dealing with matrix and vectors rather than with scalars. When you have the right libraries like NumPy, you can compute complex mathematical matrix multiplication very easily with just few lines of code. So let's begin the lecture. So let's see what are the contents of this course, of this first module. So the first module is just the introduction to the very important topics of linear algebra that is needed for machine learning. So let's see what are the contents in this module. So I will be covering these topics: the basic introduction to linear algebra and mathematics, equations for machine learning, then matrix, then vectors in linear algebra. So what are the mathematical objects in linear algebra? So as I told you, linear algebra is a field of mathematics that is universally agreed to be a prerequisite to a deeper understanding of machine learning. And in linear algebra, the data is represented by linear equations, which are presented in the form of matrix and vectors. And when you are dealing with linear algebra, the package you use will be mostly the NumPy. So the NumPy will be covered in the second module of this course along with basics of Python. Okay, so the first module is only about linear algebra. So you can see the mathematical objects in linear algebra. The first one is the scalar, the second one is the vector, the third one is the matrix. So see the difference between them. So scalar is simply a single number. Okay, so any single number, any individual number is thought of as a scalar. So for example, you can see in this slide, the value 24 is a scalar. Then what is vector? Vector is an ordered array of numbers. It can be in a row or a column. So a vector is a ordered array of numbers. It can have either a single row or a single column. A vector has just a single index, which can point to a specific value within the vector. So in this, for example, the v2 refers to the second value within the vector, which is -8, correct? So as you see, the vector has either a single row or a single column. So v1 will be the first value, that is 2, v2 will be the second value, that is -8, and v3 will be the third value, that is 7. So this is the vector. It will have either a single row or a single column, whereas scalar is a individual or a single value. Then the third one is the matrix. So matrix is an ordered two-dimensional array of numbers, and it has two index. The first one points to the row and the second one points to the column. For example, in this matrix, if I say m2, 3, it means the value in the second row and the third column. So the matrix has two dimensions. The first dimension is the rows, by the second dimension is the column. So if I say, you can see that the matrix has 2 rows and 3 columns. So we write it as 2 cross 3 matrix. Okay. So 2 is the 2 rows and 3 is the 3 columns. So 2 rows and 3 columns. And if you want to access the value 8 in this matrix, it is given by m of 2, 3. So which means second row and third column. So this is how to access the values. A matrix can have multiple number of rows and columns. So a matrix can have any number of rows and columns that we will see later. A vector is also a matrix, but with only one row or one column. Okay, so this is very important. So these are the three mathematical objects: scalar, vector, and matrix. So you can see here, this is again a matrix with n number of rows and n number of columns. So m is the row and n is the column. Okay. So finally it has m number of rows and n number of columns. So this is a matrix. Then the next data object that is not so popular in linear algebra is the tensor, which we will see later. Though the matrix is a way of writing similar things together to handle and manipulate them as per our requirements. So in data science, generally used to store information like weights in an artificial neural network while training various algorithms. So these things you must know. A two-dimension array of numbers, for example, you can refer many matrix which are available in the internet. So you can just go through how a matrix looks like. Okay, so there are different types of matrix, and you can see the terms related to a matrix. The first one is the order of the matrix, then square matrix, then diagonal matrix, upper triangular matrix, lower triangular matrix, and scalar matrix, identity matrix, column matrix, row matrix, and finally the trace. So what are these? So the order of the matrix, it is nothing but how do you represent the number of rows and number of columns. So if the order of the matrix is 3, 4, it means 3 rows and 4 columns. So you can represent any matrix by its order. So the first dimension should be the row and the second dimension should be the column. The second one is a square matrix, the matrix in which the number of rows and columns are equal. Okay, so for example, 2 cross 2 matrix is a square matrix. 4 cross 4 matrix is a square matrix. So the number of rows should be equal to the number of columns. The third one is the diagonal matrix. A matrix with all the non-diagonal elements equal to 0 is called a diagonal matrix. Okay, so I repeat, a diagonal matrix is a matrix with all non-diagonal elements equal to 0. So all the non-diagonal elements of a matrix will be 0 is called a diagonal matrix. Then upper triangular matrix, square matrix with all the elements below the diagonal equal to 0. So the upper triangular matrix and lower triangular matrix both are square matrix. In the upper triangular matrix, the elements below the diagonal should be equal to 0, whereas in the lower triangular matrix, the elements above the diagonal should be equal to 0. Okay. Then the scalar matrix, the square matrix with all the diagonal elements equal to some constant k. Okay. So scalar matrix is also a square matrix with all the diagonal elements equal to some constant k. Then the identity matrix is a square matrix with all the diagonal elements equal to 1, and all the non-diagonal elements equal to 0. So all these I will show you later when we do the operations on these. So the scalar matrix and the identity matrix. Identity matrix is a square matrix with the diagonal elements equal to 1 and non-diagonal elements equal to 0. Then we have the column matrix, the matrix which consists of only one column. Sometimes it is used to represent a vector. Then we have the row matrix, matrix consisting only of row. Then we have the trace. It is the sum of all the diagonal elements of a square matrix. So the trace is the sum, it's a single number. It is the sum of all the diagonal elements of a square matrix. So these are the terms related to the matrix. So you can see what is an identity matrix. So how an identity matrix look like? So the diagonal elements will be 1. The non-diagonal elements will be 0. So an identity matrix is a given square matrix of any order which contains the value 1 on its main diagonal elements, while the rest of the matrix equals to 0. Okay, so this is the identity matrix. Then what are the properties of identity matrix? So you must know what are the properties of the identity matrix. So an identity matrix is always a square matrix. So this is the first property. It should be a square matrix, and the order of an identity matrix is always n. Okay, so there is equal number of rows and equal number of columns. So which refers to the dimensions n cross n, meaning there is always the same amount of rows and columns in the matrix. So if it's a square matrix, then you can easily understand what is it. An identity matrix is capable of multiplying any matrix with any order, as long as it follows the rules which I have given below. If in the multiplication, the identity matrix is the first factor, okay, you can see there are two matrix multiplication. So the first matrix is the identity matrix itself. So in this case, the identity matrix must have the dimensions with as many columns as the matrix it is multiplying has rows. So you can see, what does it mean? In this case, the identity matrix should have the number of columns that is equal to the number of rows with which it is multiplying. So you can see the second matrix has 3 rows and the first matrix has 3 columns. So this is fine, this is compatible. And how the multiplication is taking place, you can see the operation. So here each row is multiplied by each column. So the elements, each element in each row will be multiplied by each element in each column. So 1 multiplied by A plus 0 multiplied by C plus 0 multiplied by E. Then 1 multiplied by B plus 0 multiplied by D plus 0 multiplied by F. Then 0 multiplied by A plus 1 multiplied by C plus 0 multiplied by E plus then 0 multiplied by B plus 1 multiplied by D plus 0 multiplied by F. So like this. So the first value in the resultant matrix is A, the second value is B, then C, D, E, F. Okay. So multiplying an identity matrix times a non-unit matrix. So the second matrix have some other values, whereas the first matrix is the identity matrix. So what happens? So this is the example. The second rule, if the identity matrix, you can see the rule, is a second matrix, okay, then it must have the same amount of rows as the matrix that is multiplying it has columns. So if the identity matrix is a second matrix, then it should have the same number of rows as the columns of the matrix it is multiplying with. Okay, so it has, the first matrix has 3 columns and you can see the identity matrix has 3 rows. So this is compatible. So here again, each element of each row of the first matrix is multiplied by each element of each column of the second matrix. So A multiplied by 1 plus B multiplied by 0 plus C multiplied by 0. Then A multiplied by 0 plus B multiplied by 1 plus C multiplied by 0. Then A multiplied by 0 plus B multiplied by 0 plus C multiplied by 1. So like this it goes on. Then the dimension, then the order of the resultant matrix will be same as the first matrix. Okay. So this is the output. The output is A, B, C, D, E, F. So identity matrix example problems. So we have 2 matrices here, 0, 2, 3, minus 9, 6, 8. Then minus 3, minus 4, minus 1. The second matrix is 2, minus 3, minus 7 and 5. Okay, so let's see some operations on this. So you can see, so let me show you the matrix once again. So just see the matrix. So the first example is the identity matrix multiplied by the matrix A, correct? So you can call it as I multiplied by A. So I means the identity matrix, whereas the second matrix is the matrix A, what I showed you. So how the operations are taking place. So again, each value in each row of the first matrix is multiplied by each value of each column in the second matrix. And the resultant matrix is same as the matrix A, that is 0, 2, 3, minus 9, 6, 8, then minus 3, minus 4, minus 1. Then the second matrix, then the second operation you can call it as 2a plus 4i. It is matrix A multiplied by 2, that's why it is 2a plus 4i, means 4 multiplied by identity matrix. So the 4 multiplied by identity matrix becomes 4 in the diagonal position and 0 in non-diagonal position. And 2 multiplied by A, matrix A, will be 0, 4, 6, minus 18, 12, 16, then minus 6, minus 8, minus 2. So you can see the operation. So 0 plus 4, then 4 plus 0. So this is the operation. This is not multiplication, this is addition. So there is no multiplication symbol. So 0 plus 4, 4 plus 0, 6 plus 0. So here element wise addition is taking place. Then minus 18 plus 0, then 12 plus 4, 16 plus 0, then minus 6 plus 0, minus 8 plus 0, minus 2 plus 4. So 1 to 1 element wise addition is taking place. So if you want, you can also perform multiplication on 2a multiplied by 4i and see the output, but here this is only addition. Okay, so you can see element wise addition taking place. Then this one, you can see the first one, I can call it as 4b plus 2i. Okay, so this is the first is the matrix B, that is multiplied by minus 4. It is minus 4b plus 2i. So again it is addition. So element wise addition will take place. So first substitute them. It becomes minus 4 multiplied by 2, minus 4 multiplied by minus 3. So the answer is minus 8, 12, then 28 and minus 20 plus 2 multiplied by I. So 2002. So you can see the output there. Then similarly, the second operation, you can call it as I multiplied by this is B. Okay, so I multiplied by B. So here the identity matrix is the first matrix. So it should have the number of columns which the matrix multiplying it has, the rows. So it has 2 columns and the second matrix has 2 rows, so that is compatible. So you can see how the multiplication is taking place. the row of the first matrix is multiplied by column of the second matrix. So 1 multiplied by 2 plus 0 multiplied by minus 7, then 1 multiplied by minus 3 plus 0 multiplied by 5. So like this, it goes on. The answer is again the second matrix itself, 2 minus 3 minus 7, 5. Then the last operation here, it is 0i. Okay, so 0i, the I is 4 cross 4 matrix. Okay, so here every item is multiplied by 0. So the resultant matrix, you can see it is a 0 matrix. All the 4 cross 4 entries are 0. Then tensor. What is a tensor? So as I told you, tensor is a quite less used data structure in linear algebra. You can think of a tensor as an array of numbers arranged on a regular grid with a variable number of axes. A tensor has 3 index, where the first one points to the row, the second points to the column, and the third points to the axis. So for example, if you say t of 2, 3, 2, it points to the second row, the third column, and the second axis. Okay, I repeat, if you say t 2, 3, 2, it points to the second row, third column, and second axis. So you can see the last diagram where it has 4 rows, 4 columns, and 2 axes. So the values in the first axis are 2121, 2494, 2562, 7732, whereas the values in the second axis 7888, 8505, 3308, 4156. So when you say T of 232, go to the second row first and third column of the second axis. So that is 0, correct? The answer is 0. So the second row, third column, and the second axis, the answer is 0. It points to the value 0 in the last tensor. So you can see the tensors. I have given here 3 tensors, one having a single dimension, the second having 2 dimensions, the third having 3 dimensions, the row, column, and axis. Tensor is the most general term for all these concepts because a tensor is a multi-dimensional array and it can be a vector and a matrix depending on the number of index it has. For example, a first order tensor would be vector, okay? A second order tensor would be a matrix with 2 index, and the third order tensor are called higher order tensors with 3 or more index. So what we have seen here is a first order tensor, second order tensor, and third order tensor. So we saw few topics. So for example, we started with the introduction to linear algebra. So the contents were only the matrix, vectors, and some operations on the matrix on these data objects. Okay. So just a recap of what we did so far. Then what is linear algebra? So then we saw what are these individually. So if you have any doubts, you can mail us. So try to read them again. I hope it was clear. If you have any doubts, you can mail us. Right? Thank you.